Yeah, good morning and good evening, guys. And we are into data processing steps. So far, we have understood like if we have any kind of missing data, then what are the strategies we do for handling that missing data. The second step, like encoding categorical data. So it's a pretty important step. In generally our machine learning models. It won't it won't process or it won't try to understand our data. So that's the reason our categorical data we need to be converted into the numerical data actually. So for that we do use various encoding.
Label encoding, simply label encoding with just replacing that numbers by corresponding which is replacing with the characters or categories by corresponding numbers. Okay, I can tell you both encoding and one hat encoding. I thought you understood, but I could explain one more time. Wait a minute. Recall whiteboard. How label encoding is working and how this one hat encoding is working, I can explain you. For example, I do have one particular column. Okay, this is my a column. Okay, and this is my column score range or something like. Okay, and so here I have less and medium or I score. Okay, so this is how the data has been repeated. This is the data point. These are the three data points only are repeated in this particular column. Okay, and if I apply the label encoding, what it will do first, this less, medium, and high, right? First, it try to understand that how many data points we have it, how many unique data points are repeated continuously, right? Okay, so high is one data point in alphabetical order. Please tell me in not alphabetical order. Less and medium, right? In alphabetical order, this high, L, H, L, and medium, M, right? So wherever this position is 0, this position is 0, 0, 0. Okay, for example, high, okay, medium, okay, and less. Okay. Now in one hat encoding and label encoding, how it will works, both will works in the same format only. But the thing is that you know if in case wherever the less is there in that particular position, it could be one. Rest of two things, it could be zeros actually. So in one hat encoding, what it will do, how many data points we have, what are the data points are repeated continuously, or what are the data points are repeated in this particular column. So those unique categories are converted into the different columns. Okay, different columns. Wherever the medium is there, so that particular position, it could be the one. Rest of two things, it could be zero. Wherever the high is there, that particular position, it could be a one. Rest of two things are converted into the zeros actually. This is how one hat encoding will work. And coming to the label encoding, you know you just see when you're arranging the order in alphabet, you know in one sorting format, then you just see that what could be the value of this one. Is it uh, when you are arranging that high, low, medium, and less alphabetical, this is the 0, this is 1, and this is 2, and if any data points are there, this is 4 and 5, something like that. Okay, see here. In case of label encoding, you will go for generating only one new column, and the column which we have direct numbers. Okay, but when coming to the one hat encoding, we are not generating the single column, we are going to be generating the multiple columns, and based on the how many for example, if we have the 5 data points are repeated repeated, those 5 data points are converted as the 5 columns. Okay, here data size, I mean data set size was increases, the number of columns are increases in case of one hat encoding. In case of label encoding, here we are not increasing that what we call mm, number of columns. We are just creating only one new column, and the existing column we can simply remove it. You're not increasing that number of columns actually, but here we're increasing that column. I hope you understood the difference between label encoding and one hat encoding, right? Deepak, am I clear or out? Okay, okay, cool. Yep. I hope the corresponding data also I already provided to you. I mean, I already did some kind of task in our Visual Studio here itself, right? Have used label encoding. In case of label encoding, so which was converted into the only one column, and but when coming to the one hat encoding, for that we are using the get dummies, and what are the columns are repeated, so that many new columns are created over here. Okay, so if it's just replacing 0 and 1, true or false means it's a 0 and 1 only. Okay, clear, right? Now let's try to be execute from the statement 1 onwards, because we need to be continue our um data processing steps. I'm going to be comment this one. Yeah, run all. If we do the run all, then all treatments what we are executed the previously till the last session, that all are executing one of the one. Mhm. Okay, cool. Yep. What's the next step? What I was shared with you last time, like after the data, handling the missing data, after that one, handling that categorical data, what could be the next?
The data processing,
These are all steps are a part of the data processing only.
pre-processing. Okay.
Yeah, it's a part of the data processing only. In the part of data processing, we do generally implement some steps. The first one is handling the missing values. Second one is handling the categorical data. What could be the next one? Feature selections. Okay. In step feature selections. So what is mean that feature selection? Tell me. Step 3. What is mean that feature selections? Sorry, it's not selection, feature scaling. Okay. What is mean that feature scaling? What is
Uh, it is uh, it is nothing but the min-max scaling and normalization standardization. Like means We are taking the values to in between 0 to 1 or minus 1 to 1
Mm-hmm.
to the main values means
Hmm. So why we need to do? No, that is okay. Feature scaling means we are scaling all the data into the same range or same scale. Then why we need to do? Is there any necessity? Now I would like to talk about features scaling concept, which is pretty important, guys, because data, it could various machine learning model, it could be the sensitive, and it always looks same scale of data. Okay, so I'm talking about feature scaling. So what are the techniques we have it that I definitely talk about it, and how to use it? Definitely we'll work on it actually. But we need to understand what is feature scaling, right? Okay. See, first, before we do understand feature scaling, what is important? What no, what why it important actually? So when we are working with various machine learning models like k nearest neighbors or support vector missions, okay, or logistic regressions, or else neural networks. Okay, so these are all different, machine learning models we can apply on top of your data. Okay, these are all are sensitive actually, sensitive or to feature scale, to feature scale. Okay, so what is mean that actually feature scale means I do have one data points. I have one particular column. I have a data point something like this. I have the ones, and one data point it was 1 lakh. Okay, and one data point it was 10, and one data point it was 20, and so I um, 5. Okay, and 15, and okay, it was something 10,000. See, when this kind of data also we see actually. Okay, so this is my column, and the column having multiple data points, but this 15, 1, 10, 20, 5, these are all same range, right? These are all one you know mm, respective range only, right? Okay, but when coming to this 10,000s and 1 lakh, it is a too far, it's a too far, and scale is also not within this range. It was it is too much far actually. Okay, so what feature scaling we do, and we if if your data it was in a, if the data which is too far for original data, so could we consider it's a bad data? No, it's not a bad data. People will generally consider it's a bad data. Okay, it's not a bad data, guys. It is also data, and which is also generated by the either machines or some situations that's happened. So in generally, people will what they do, if the data which is not within the same range, then simply they can try to remove it. That is a bad approach. Okay, so the data what we have it, this spikes also, it is important. So, and but when we are trying to build the machine learning models with this original data, okay, so your model, it could be predicting wrong results actually. Okay, it may affect your accuracy. Okay, it might be dominating your model predictions. Okay, without scaling, one features it could be dominate other feature as well due to the large number of this particular numbers. Okay, so that's the reason we need to scale all the features with the same range. Same range means with either it could be 0 to 1, or else -3 to +3, or else -4 to first. If this entire data, if you're if you are scaling into some this range, then all are the same scale only, right? Okay, so that particular situation, we can improve the we can improve the machine learning performance. Okay, and we can increase the training stability also. Here, when you train your model, it is not it won't perform like stability kind of performance. Okay, and but when we are scaling your data, and with all in the same range, and if we train your machine learning model, it could performs better actually. Okay, clear? I hope you understood, right? What is the importance of the feature scaling? Yes, data it is, we can't predict that, data it could be this range only. In some situation, you might be, you might be get some kind of, peaks data. That peaks data also it could be required when you are building the model for getting the a better performance. Okay, if you remove that kind of spikes and if you train your model, and of course your model can be performing good only and your accuracy everything is good, but when it is a real time in some situation if you're getting that kind of spikes kind of data, then it could be the problem and it could predict as the some kind of bad results. Okay, so you can the performance it might be reduced. So that's the reason what we do actually, we have to scale that entire data as same scaling or same range, that kind of technique we can call it as the feature scaling. Clear?
Yes, Sanjay.
Yep. Any questions? Any questions?
Generally, what scaling would be preferred, a normalization or a standardization scaling?
Hmm. Good question. Okay. So we do have various mm, yeah, yeah. We do have various scaling methods are there. Okay. I would like to talk about what are the feature scaling methods. We have lots of method, feature scaling method. From that one, most of the time we are using the standardization. I'm not saying that this is the best thing. I'm saying that various methods, standardization. Okay. Next one is min-max scaler or min-max scaling. And third one is, it could be like various other scaling techniques also there. So I'm talking about only standardization and min-max scaling. Okay. What standardization do actually? Okay. So standardization, it could be range of, mean, it is not range actually. So the mean it could be the zero, and the standard deviation it could be the one. So whatever the data we have it, the data we are converted, your mean value is the zero, and the standard deviation it could be the one. That means if you are distributed your data points after standardization, you will get this kind of curve. Okay, and exactly the mean it could be zero here. Most of the data could be false in a range of zero only. Okay, and the standard deviation is the one, so that it could be the -1, it could be the +1, and so it's +2 and +3, and it's a -2 and -3. Okay, so 99.999 data it could be false within this particular region only. Okay, is it clear? So so whenever your data it could be Gaussian like data, that Gaussian means when you're distributed your data, you will get some normal distribution, right? So when you're getting the normal distribution kind of data, that particular situation, standardization is the good approach. Okay. And min-max scalar means, we are taking that entire data, you're taking your entire data, and what could be the mean value, and what could be the, max we are have it, right? So based upon this one, you're converted entire data between 0 and 1, between 0 to 1 only. Okay, so in case of min-max scalar, the range of the data it was 0 to 1. It is 0 to 1. When coming to the standardization, which is not 0 to 1, it could be anything. It could be -4 to +4 also. It could be -5 to +5 also. It doesn't various. Um, it could be like mean plus standard deviation. Standard deviation based on this particular mean and standard deviation, that if you distribute it after scaling, you will be getting this kind of normal graph, normalization graph. Clear? I hope you understood what a standard deviation and min-max scalar. In min-max scalar, the range of the data you're scaling into 0 to 1. In case of standard deviation, we are scaling your data into the some plus or minus kind of thing. Okay.
Yeah, clear, Anjan.
Yep. Let's try to work on the scaling kind of thing. For feature scaling, we do have various methods are there, right? So let's see. I mean, I would like to see that, what is my data points, and so from this particular data points, you just feel it. What are the important numerical things? So, this feature scaling we can apply only on numerical kind of data. Okay. So here passenger ID not required. Survivor is like 0 or 1 only, right? Okay, this is also not required. Uh, P class, so all are in the numbers only. And age, you just see that age, it's a 22.0, 38, 26, 35, and some data it was in a numerical, right? It is some range. Okay. And tickets is so coming to that far also that it's 7.2 and 71 and 7.9 53. See, these are all the two different numerical kind of data we do have it. And the data it might be with 0 to 100 something like that only, but I would like to apply the feature scaling on this particular, on these two techniques. I mean, these two columns, I can choose one for standard scalar, one is for min max scalar. Okay, here. Okay, let's see. For feature scaling, we do have a method. Is we do use Python. Oh shit. We do use feature scaling. For that one, we need to import the scalar, scalar, and within that one, we do have preprocessing, and we need to import the standard scalar. Direct method we do have. We can use this standard scalar. And so you can directly apply the multiple columns also at a time. So what are the columns I would like to work on it? First one is age. Okay. Second one is for. Right. These are the two columns I would like to apply standard scalar. So first we do have a standard scalar object. So I'm SS. SS means a standard scalar object, or else you can give some kind of scalar standard. Give it some proper names actually, so that and people will try to understand what exactly this one standard scalar. So this is how we can able to create the object, and the object name is scalar standard. So next time onwards we could use only this object only. So here we have a fit transform method is there. We use this particular fit transform method, and there we have to provide the columns what you want to be, scale it. So the first one is the age, and the second one is, what is that, for, right? And these two, it should be within this square brackets only. These are the two columns I want to be scaling it. Okay. Yep. Okay. So once if you fit a transform is done, and it could be returns, and I would number columns. These are the two columns I want to be work on it. And okay. And next one is, in place of this one, I'm just simply give it. Okay. So it's very simple, right? Okay. Now this entire thing I would like to be assigned to my original data. So you just give it. So it could be transform and it could be return the result, that return result we are holding into this particular columns again. Okay. And you just simply run it. After running, then we try to understand or try to see that the data, how it was distributed. See, you can try to understand in case of age, it was converted into some plus or minus kind of things, right? When coming to the for also, it was converted into some plus or minus kind of thing, right? All data it was generated in the some square, same square. Okay. And I would give you some the code for the min max scalar as well. Okay, so for min max scalar, we can use min max min max scalar. Okay. And so here we can in place of min max scalar, we can use this one. In case of standard scalar, we can use min max scalar and scalar min max min max. Okay, so we can give it the same thing over here. This is how we can work with both. Clear? This is the code, you can use it. I just tried with the standard scalar. You can try with min max scalar. Okay, and now if you want to see that, some kind of visualization how this particular data it was distributed, let's see some kind of visualizations. And for that one, I would import a mat plot lib as plot as a plt. I want to see that, how um this was distributed. Okay, and import seaborn. These are the two different libraries for see that visuals. So before scaling, oh shit, I missed the data, right? Yeah. Mhm. Let's anyway, I can see that. Okay, I would show you both actually, like before scaling and after scaling. I would show you. Hmm. Okay, I'm just copying. I'm just copying original data. Okay. Df dot copy. Uh, I just saved this one into this particular variable because after scaling, I want to see that the difference, right? Okay. Mm, yeah, okay. Okay. So Seaborn as SNS. Okay. Now before scaling and after scaling. And after scaling, I want to be display that. I want to visual the data of my any one of the variable. You can decide which variable will distribute will see that, how it was distributed. So for that one, we do have SNS. Now within that SNS, we have plot for see that, how it was distributed. We can use plot and df underscore original. And within this, we do have fair is our column, and I want to display this particular column, and KD equal to true, and plot. So PLT title. So what title will give it before scaling? Okay, and so let's see that the plot show. Now after scaling, let's see, I'm using DF only directly. Okay, so this is after scaling. So syntax error. So here we have to close this one, and here we have to close this one. Now we can run it. Now model matplotlib, right? So what we do, what we have to do, we need to import that matplotlib pip install. So on Jupyter itself, we can install it. You don't need to open the terminal as well. Matplotlib. So this is how we can directly install on our Jupyter notebook. So we are working on this environment only. See, I'm working on this environment. Yeah, it is done. And meanwhile, we can try to import Seaborn as well, pip install. Okay, done, right? Now let's see that same code. We can run it. When you're running, see, this is before scaling. The data range, it was hmm, So count wise, it's counting it, it's just counting it. See, careful observe here. Here we have zeros, hundreds, 200s, 300, 400, 500. So this is the range of data we have it. Most of the data it was fall between 0 to 100 only, right? Okay, 0 to 100 only. So rest of the data it was in some, it is distributed towards right skew, right? So, but same, which you're not changing your data thing, and but your data it was see how it was distributed. So most of the data it was fall between 0 to, so this is your mean value. Okay, but most of the data it was here itself. See the count wise it is not changed. So this is the distribution you're not changed it, but thing is that most of the data falls here itself. Clear, right? So I hope you've seen that how it was distributed and all. And if you have any questions like in terms of features scaling, I can try to be share with you some more points if you need it. Hello.
We understood.
Yeah. Now, after a feature scaling step and feature selection is important. Step number 4. So, which feature we need to be consider to train your model? That is also important. Actually, that is the fourth step. Okay. So, feature selection. For feature selection, and it's a pretty important. So with help of this one we can reduce the overfitting. So overfitting, so here I would like to ask you some questions. What is overfitting and what is underfitting? So there is a two things we need to understand. It is a important interview question as well. You will face this kind of question: what is overfitting and what is underfitting? See, I do have data. This is my training data. Okay, known data. I can simply say that it's a known data. This known data only I'm giving for training purpose. Okay. With the help of this particular training data, I have built ML model. I have built ML model. Okay. For test this model for evaluation purpose. For evaluation purpose, I'm using the same data. If I'm using the same data, you will get the good results. You will get the good results. That means the error is less. Okay, we are getting the good results, and that means error is very less for the known data. Now what I'm doing actually for the same model, for evaluation I'm giving some kind of test data, that means unknown data. So this is the data I couldn't use for training purpose. Okay, I'm going to be using for testing purpose. Whenever I try to be model evaluation, I get some kind of bad results. Okay, so that means here error it could be high. So this kind of scenario we can call it as the overfitting. So for training, it is working fine, but when it comes to the unknown data, it is failed to predict, or it is failed to predict correctly. Okay, so this kind of scenario we can call it as the overfitting. So underfitting in the sense in both scenario which was not giving good results. That's it. That is underfitting. So there is a two kind of these are the two different issues you might be challenges you might be getting while you're building your machine learning models and all. Okay, so to overcome this one, to overcome this overfitting, okay, in general why we are getting this overfitting, that we need to understand. See, for example, I have the 1,000 columns are there, or 5,000 columns are there. 1,000, let me consider I have 1,000 columns are there in my data set. Okay, I'm going to be using this 1,000 data sets, 1,000 columns to build the model. If I'm using this 1,000 columns to build my model, that particular situation, which is trained with huge or huge, it might be trained with some null values, or it might be trained with, um, so many features, right? So that definitely it will be increase the accuracy and all. Okay, but from this one, most of the data points or most of the columns are not much directly correlated to your target value. Okay, so that is the reason we need to be select only important features, or what are the features are most affecting on your target variable. So let me take it. This is my data set. This is my data set. This is my target variable. Okay, rest of all inputs x1, x2, x3, and so on. See, this x1 was have some kind of a relation with the target variable, but this x2 and the target, there is no relation. If there is no relationship between these two, why we use? Okay, if this is the thing which is not affecting anything on your target variable, then there is no point to train this data, right? Okay, if you're able to remove this particular column, and what are the features are most affecting on your target variable, if I use only those columns, then you can increase accuracy, and you can computationally also we can reduce it, and your machine learning will be trained with limited data only, right? If you train with huge amount of data, it won't perform well actually. Okay, is it clear? Is this clear or not? So
Yes, sir.
for feature selection, we do use various techniques also, like but the best thing is that correlation matrix. Okay, the best thing is correlation matrix. For that, we do use import. So from, I think we are already imported C1 and Matplotlib, right? So we have SNS heat map. So with the help of this heat map, we can show you that graph, and with the help of CORR, which is give the relationship between each and every attribute or features inside of your data set, and not equal to true, and so plot show. So you just see that okay, see, could not convert a string to float. See, there is some columns or numerical things. Okay, so this unnecessary columns we need to be remove it. So you just tell me as a just think that from this particular data set, what are the columns we it is not no, it not required for us. Tell me, just by see you can tell me. Is it required passenger ID? Do we require the passenger name? Tell me. Do we require these two features?
Mm. Name is required, I think, right?
Why
Passenger IDs.
name is required? Hmm? Name is if he if I give
Either
some name by the name, if I give the name, if this particular name, people will if a name which is
either
not,
ID or name is required.
no, why it is required. My question is that when you're generating the data, of course this is required. When you're ticketing, then it is required passenger ID and name. But when you're building that, this is a project is for survival kind of thing, right? Okay, is there any dependency on the name? If we have a name start with this character, this person will be safe. So do you have any kind of guarantee for that? No, right?
Mm.
See, if
Yes.
someone have some name, is there any chance to live alive? Tell me. No, right?
No, no, no.
It is a
No.
disaster, right? If you have some kind of height, this kind of range, or if your age is this kind of thing, And yeah, for example, if age, yeah, there could be chance of age. If the age is 78, 98, he is not even survivable on this particular disaster, right? Yes or no? If we have age around 25 to 35 or 45, it could be some kind of medium range, and he might have a lot of strength. So might be there could be chance, right or not? Okay. Hmm?
Yeah, Anjan, actually, I have one doubt here.
Hmm.
We can do like this also. I think, uh, for example, if we by taking the by checking the collinearity means
Hmm.
high collinearity variable,
Hmm.
so we can take that high collinearity variable and we can do x and y axis and we can do prediction. After that, we can remove one by one variable if there is a in the training set only. Is that also we can do?
I would give you that two things here. Okay. See, multicollinearity is a very big word. Okay. And so multicollinearity. Okay. And correlation which gives the strength relation how strong two
No,
variables are.
actually, is wrongly I use the multicollinearity word. Actually, I am talking about the correlation only. I am
Hmm.
saying that in the total data set, we can take the variables which is highly correlated. We can do the x and y, we can take that as x and y axis y variable, and we can do prediction. Before
So
means I am saying that before before
got
removing the variables.
it. My question is that here we have only 10 features. Okay. And
Okay.
if I have 1,000 features, then what you can do? You can try with each and everything by one after one. It's manually it will take a lot of time. Yes, that is also good approach. But thing is that when we have less number of features, that we can do. When we have more number of features, then what you can do? Okay. So that is a good thing is that correlation matrix, it will give you the relationship between all the features in one graph itself. Okay. You just follow this one graph and you can try to understand how both are you what you said, collinearity and correlation, everything is get it from here itself. Okay. And we have RFP also, recursive features elimination, recursive feature elimination, and some of embedding methods. Okay, so different feature importance. We need for feature selection, we can use different methods. And first one is filter methods. Okay, for feature selection, we do use various methods. I can list you selection. For feature selection, we do use various methods. From that one, the first one is a filter method. So for filter method, we can use various tests, correlation. Either you can use correlation matrix, okay, or else chi-square test. Chi-square test, it could help you for categorical variables. Okay. For numerical kind of thing, we can use correlation. For categorical thing, we can use chi-square test. With the help of this one, you can filter it. What you said? Filtration, right? Okay, so this feature is important to us, or no, I would like to be test individually, right? Okay, why do you go with that long run? We just use only these two techniques, and that's how we can filter it. Second one is wrapper methods. What is that? Wrapper methods. And coming to that wrapper methods, you know we can use recursive feature elimination. So from that one, RFE is a very important thing. Recursive features eliminations. Okay, so we can train the model and remove the least important features. Okay, and the next one is embedded methods. So this embedded methods, it might be decision trees. With help of the decision trees, we can select or else random forest. Okay, and XGBoost. So different methods we can use it for selecting the best features and all. Okay, so these are all machine learning only. Decision tree, random forest, XGBoost, even RFE also, logistic regression we could use it. Okay, so these are all machine learning techniques only. Okay, but we are not started any kind of machine learning algorithms, right? you know that basic statistical kind of thing. That is the reason I'm going to be using the filter methods, correlation and chi-square methods. Chi-square method, it could help you for whenever your data which is a categorical kind of thing and I want to be tested, then you can go ahead with the chi-square test. And if you know, last time, I mean, 5 minutes back, what I do actually, I've used label encoding and one had encoding, right? Actually, it's a categorical, but I converted it into numerical. Could I consider as the numerical? Is it, even after you're converted categorical to numerical, it is not exactly numerical actually. It is a categorical, qualitative kind of nature. For the qualitative kind of natures, data, if you want to be tested with, how it was, you know, affected your target variable, that situation we could use the chi-square. And whenever your data, which is purely numerical, quantitative data, that situation, that those kind of variables only we considered as the correlation matrix. Don't consider everything as the correlation only. Correlation, it will work on numerical data. It's not numerical, it's a quantitative. And chi-square, it could work on qualitative. Clear?
Yeah, okay, clear.
So what do you do? Tomorrow session, I would try to work with feature scaling methods and first correlation and chi-square, and later I can try to explain these embedding methods and wrapper methods. Okay, yep. Cool enough. Thank you so much for your time, and please join for Python session uh, if you want to be follow for Python class as well.
Okay,
Bye
then
guys.
thank you.